my screen. We have Robert's iPad, me, Hopeful and Victory, Jeanette, Holly, Frankie, and Andrea. So we can go pretty high today. So we're going to start out with Andrea. And Andrea, you get to be, everybody needs to have your camera on so I can see your hands. And we're going to do all from 9, last from 10. Oh, Frankie's now at the end. So Frankie, if Frankie shows up, he can be 10. But all of the rest of us, every one of the rest of us have to have a finger. One of your fingers don't work. So it's got to be your thumb on one of your hands. Don't care which one it is. And we are going to practice reading. So I don't know how you have it on your screen, but I'm going to give you your name and you have to remember it. So Frankie, you're going to be the units. So Frankie gets to keep all of his 10 fingers. Andrea, you're going to be 10s. So sometimes you're going to have to say your name. Like you'll have to say, like Frankie will have to say 7, and then you're going to have to say teen if you put a 1 up. Or it might be 20, and then he'll say 2, but like the teen numbers are going to be tricky because if he has a 1 and you have a 1, then you're going to have to say 11. So it's those teen numbers for you that get a little tricky. Yep. Right? So Holly, when you say your name is going to be 100. So you're going to say whatever numbers you have up, and then you're going to say 100. So at Jeanette's house, we've got 2 kids over there. So, well, 1 kid, but we got 2 people. So we have, we've got one that's going to be a unit. You guys pick yours. And so you're just going to read your numbers straight. And then Jeanette, if you're going to be in the same position Andrea is. So if it's like, but after, so after you guys say your number, so it's not Ben, it's not Ben, what's the other one? Ben and
Alex.
Alex, your name was gone from my memory. So Alex, after you say your unit, though, you have to say the word 1,000. So if you say 1, then you're going to say 1,000. And Victory, you're hundreds again. I am going to be the teen, and you're going to be, or I'm going to be units again, and then you're going to be, and after I say mine, I will say million. And then over here, the very end, you're going to be that teen thing. You have that T, 10, 11, T. So if I had a child that was like, we're going to do this with little kids, if they wanted to say like 1 T, and then the next person would say 1 for 11, I would let them. So if it hits 1 T, because the teen numbers get really confusing, so we could say 1 T1 and 21, or if they want to say 2 T1. So instead of 20, because that 1 and that 2 gets really confusing when we play the game. So if they're little, 1 T and 2 T are perfectly acceptable things to say. So we're going to go, everybody's going to have some number of fingers up. And so you're going to randomly put your fingers up. It doesn't matter how you do it, both hands. You're going to read the fingers up, and we're going to go down the line. So we're going to start on my left where it says Robert's iPad, and we're going to read our numbers that are up in the order in which I gave them to you. So
are we supposed to be able to see your screen right now?
Yeah, you can't see my screen? But do you see everybody's fingers?
I see you.
Oh, okay. Does this help? The gallery view? I want to be able to see everybody. Gallery view helped?
Oh. Yes, we see everybody on gallery view.
You see everyone?
Yes.
Okay. I don't see everyone. Now, I'm short a few people.
Well,
and we're not in the same order that we were, so this will be a little bit tricky. Do the best that we can, guys. If we lined our children up in a classroom, this would be much easier. So we're going to start with Robert's iPad, and then it's going to be me, and then it's Jeanette and Holly. Do you come? Are you the hundreds? Okay, so you're going to have to remember your order because now when I moved my thing, you guys all shifted around. So I gave you the order, so we'll do the best we can. Maybe we won't go all the way up to 1 million. Maybe we'll pick 4 people, and we'll do just to 1,000 if this doesn't work. So you're going to hold up your fingers. Can you see me?
Yes.
Yes.
Okay, so we're going to read starting with Robert's iPad.
Am I reading yours or mine?
You're reading your own. And so you're going to say your own, and then you're going to say whatever you are.
Okay, 90
19?
billion?
Well, you would just say 90, because then I have to
19.
say mine, and then I have to say, because I have the comma. So 94 million. Then who's next? In the thousands. Is it Holly?
No.
You guys are T's and 10, so there's somebody who's 100,000.
We're thousands.
There's 100,000 somewhere. Okay, what?
100,000 or 100?
Well, you're gonna be 100. Well, we have 200s.
Okay.
So we have 100 in the thousands, and we have a regular 100. Okay, you know what? We're gonna do just 4. I think that will be easier. So I'm gonna pick. Let's do Hopeful and Victory, Holly, Frankie, and Jeanette. So let's do Holly. You're on the end of mine. You're gonna be the ones. And Hopeful and Victory, is she still there, or I just lost her? Oh, she's there.
Yeah, I'm back.
You're back? Okay. So Holly.
I keep losing connection.
Okay, so I'm going to have somebody else do it since you keep losing connection. So we're going to do, I have Holly on the end. We have Robert's iPad right here. So she's going to be our T, teen, 20, 90, whatever. Frankie, you guys are going to be hundreds. And Jeanette, I'm going to have you guys be thousands. So here's what you're going to do. You're going to read your number, and you're going to say 1,000. And then they're going to read their numbers. So starting with Jeanette, can you read your number? Alex, can you read hold your fingers up.
So I'm 40,000. Oh, 30. No, you're not 30, yo. How many fingers?
3,000.
Right.
43,000. 3,000. 500. Okay.
30.
And units are
4. Is that me?
it was at the end. Were you 4? Okay. So we had 43,534. Is that what we had? I'm going to write this down.
Yes, I think so.
Okay, Andrea, can you write it down? Do you have, I'm looking for a pen and I don't see one. So can you write that down? So let's do another one, and let's just do it in 100. So I'm going to take off the thousands, and we're just going to do hundreds, tens, and units. So who had hundreds?
765.
765. So what we want the kids to see is that each person has, though the number is the same, that everybody gets a new name. And we're going to work on just naming the numbers. That's all we're going to do. And then once we have this whole idea of the fingers up, we're now going to, so we'll do that 5 or 6 times. Maybe we spend a whole classroom shifting kids around. When I did it at our house, we cut out fingers and palms and pasted them on paper, cardboard. So we made hands and pasted them on construction paper, and we moved fingers up and down. And we cut off one finger. So of most of them, except for one of them had 10 fingers. And I did not explain why. I just left it, and then we asked if they want to ask questions, that's fine. But we don't want to tell them why. We want them to think it through when we come to the end. So we're going to read up fingers, and then we're going to go read up fingers, and then we're going to read down fingers. So let's start in, let's do T numbers. So it will be just the last two. So it'll be, let's do like 25 or 35. We're going to read the up fingers and then the down fingers. So somebody should have 9, and Holly, you should have 10. So you're able to use all 10 of yours because you're reading units, right? Okay, so
Yes.
we're going to read the up fingers, which are what? Who has our teen numbers?
Two.
Our 20, and then Holly, what's
20.
yours? So 20. You got to
I
have
think
one
I'm
down.
confused.
So just
One
put
down.
some
Okay.
number of fingers
So put
up and
this one
some
down.
numbers down. Yep.
Okay.
You want to have some number of fingers up and some numbers down. So you have 28, right? Yours is 8. So we're going to write 28 down. Andrea, did you read that? Did you write it down? Okay,
Yes,
now I want you to read your down fingers. And remember, if you have 9, one of your fingers don't count. So can you read your down fingers?
70.
And then Holly, how many are yours down?
How many are down?
How many are down?
Just one.
You have 10, so you had 8 up, so you
Yes.
have how many down?
Oh, I have 9 up.
You have 9 up?
Right? Yes.
Oh, okay, so she had 9 up, so she should have 29,
Sorry.
and she has 1 down.
Okay.
And so
I
how
think
many
I'm
do you
on
have
board
down?
now.
1. So
I
she
have
has-
1 down.
Okay, so what are the 2 numbers that you have, Andrea?
Hold on. So first was up 29,
Uh-huh.
right? And down, shouldn't it be 81?
Okay.
Should be 81. No, it should
I
be
don't know.
71.
71.
Right? She had
Oh,
7
yes.
fingers. She had 7 fingers
Yes,
up, and we had
yes.
1 down.
Okay.
All right, let's do this in we can, so what we have found by reading the up fingers and the down fingers are reciprocals in 100. So we can show this. Let's go to my share whiteboard. So read them to me again. We had 21 and 79.
29 and 71.
So 71, okay, so it's 71.
29 and 71.
Okay, 71 and 29.
Yeah.
So if I had 100, I could subtract 71, and I would get, that would be the same as 29. And if I had 100, and I subtract 29, I would get 71. And if I added these two together, 71 plus 29, I now have 100. So we want to practice reading up fingers and down fingers. And there's a thing that happens because we can do, with our fingers, we can have all kinds of different groups of 7, right? Which is pretty interesting for kids, no matter how they group them, right? No matter how the different ways you make 7, 3 on one hand, or 2 in a group plus 1, plus another 1 plus 3. I don't know if you can see mine, right? So you have this 1 over here, and these here, or these, then these, and these. This is still 7, however it is that I group them. So there's this thing that happens that they begin to realize that when you have the bars, and we talked about when we add numbers together. Let me go to my bars. I have to just share screen. Hold on. Stop share. And I'm going to go to new share screen. I want to go to Cuisenaire rods. When I do this, and then I do this, right? What I notice, what most people notice, is that one is getting smaller and one is getting larger, the other side's getting smaller by 1. What you don't realize is that we're taking 1 from here and adding it over here. Whereas when we're doing it with our fingers, the children see that you're just moving fingers in and out of groups of up fingers and down fingers. right? It's just a group. And so we have two separate groups, and that's what we want to play with. And so we want to work on all from 9, last from 10. And I'm going to show you why. So this is our first introduction to all from 9, last from 10, and place value. And one of the things, after we figure out this all from 9, last from 10, we want to go and use the Cuisenaire chart, which is this little bugger right here, which is absolutely fantastic. And I'm going to move you out of my way. And what we want to do is practice for a couple of days. Where is my annotate? Here we are, my spotlight. Reading. So these are our up fingers and down fingers. Well, this is we have here 100,000, 10,000, 1,000, 100, 10, and 1. And we can, by reading this chart, read all kinds of numbers. And we can see the 1 through 9 here, 1 through 9 here. But what happens is once it gets 9, it becomes 10 on this next line, and it gets a new name. And then we do 10, 20, 30, 40, 50, 60, 70, 80, 90, and we hit 10, and it gets a new name. This is 1, this is 10, this is 100, this is 1,000, this is 10,000, this is 100,000. And we want them to see that when we get to 1,000,000, it's 1 million, 10 million, 100 million, and then we go to 1 billion, and it's 1 billion, 10 billion, and 100. We want to see that repeating pattern. And it makes it easy for kids to go right from 10 to, you see how Cuisenaire does 10 plus some number. So we can do that here. 10 and 2 make, you can read it as 12. So where is Alex? Alex, you're here? Are you here, Alex?
Yeah.
Do you want to be my guinea pig?
Sure.
Okay, we're going to practice reading some numbers, Alex. And I'm going to point, and I want you to read the number that I point to. So this one is right here. This is 30, and then it has a comma. So we're going to do that as 1,000, 30,000. This is 1,000. This is 10,000. This is 100,000. So if this is 10,000, what will this one be?
Around 30,000.
If this is 30,000, what will this one be?
70,000.
Okay, if this is 1,000, what will this one be?
7,000.
If this is, well, the 10s are harder, but you know these. If this is 10, what is this one?
90.
Okay, if this is 90, what is this one?
90,000.
If this is 500, what's this one?
500,000.
Okay. If this is 3, what is this one?
300. That's so easy.
What's this one?
3,000.
Okay, so I'm going to give you some numbers to read. I want you to just to read, you don't have to read the 100,000 part. I just want you to read this part right here where it's 200. When I point to the comma, I want you to say 1,000. Okay?
2,000.
Well, it's going to be 2. How much is here? Is this 2,000 or how many thousands are here? 2 of them are
200.
200.
4. No, 40. Five.
Now I'm going to point to the comma.
5 of the thousands. Kind.
Yep. So 45,000. And then what's this one?
600. 50. 2.
That was fairly painless. Have you been reading big numbers? So like, are you cheating? Like, have you already done this before? Okay, so let's read this one.
900,000.
Now remember, we're not going to say 1,000 until I touch the comma.
900 to 20,000 471.
Okay, so there are, if you look around, there are lots and lots of exercises that you can play on this chart, multiplying by 10, dividing by 10. There's lots and lots of things you can do on the chart. We're going to just do this strictly today as an introduction to place value, because you'll see that what Cuisenaire has the kids do when they start with addition and subtraction is they're going to do 10 plus some number. So we're going to do 10 and 5. That's 15, right? You'll see 10 plus 5. 10 plus 8 is 18. He doesn't just give them the number out of context. Even in book 2, when he has kids add 356, he has them separate 3 of the hundreds, 5 of the tens, plus 6. So he's really working on place value, and that has an implication as they get later on for multiplication, because they want to be able to shift these things around and use them. So his emphasis is on really on learning the rules for the distributive property, the associative property, the commutative property, and then place value, using all of these to turn hard problems into easy problems. So we're going to look at making 10. We're going to look at all from 9 last from 10, why that works. So let's, not when they're little and we're introducing 10. So hold on. I just want to show you guys where we're going with this. So I'm going to do, I need my whiteboard. Okay, sure. All right, all right. So we talked about last week when we had families of common difference that I could change 20 minus, hold on, that's a plus, minus 18. I can just, with a family of common difference, subtract 1 from each of those and change that into 19 minus 17. And it doesn't matter if this is a number like 46 minus, let's see, 18. I can change that by adding 2 to these, and I can change it into 48 minus 20. So we're going to use the rule. So we're making things easier, but we can do, there's another way that we can do these, knowing what we know about making 10, all from 9, last from 10. So we'll work on knowing our bonds in 10. So one of the other ways that we could solve, let's see, do 18 minus 9, right? We could add 1 to this and change it to 20 minus 9, or add 1 to the 9 and make it 19 minus 10, right? We could add 1 here, add 1 here, and now we have 19 minus 10 for an answer of 9. The other thing we could do is count up and make a 10. So we could say, when I said to you, some things are difference, 9 plus something plus something else equals 18. And you're going to see this in Common Core, and it drives parents crazy, but there's a reason for doing this. And it's not all bad, it's just the teachers aren't taught to use it. So we can count up to 10. So how far is 9 from 10?
1.
And then how far from 10 to 18?
8.
So what is our difference? Is it the numbers in these squares is what? 9 plus 1 is, or 8 plus 1 is 9. Someone? All right. So we have all from 9, last from 10. We're going to work on mostly making 10s and getting our kids to, you'll see that Catania does that. He has when he's making numbers, if we're going to add 7 plus 8, he will have students take an orange rod and then place another rod next to it. Find out how much these two make. And we change that into 10 plus 5 because he's really working on place value. And the other thing we're working on is getting numbers, working with numbers that end in 0. Because kids aren't prone to make mistakes that way. If we have to do this, because I did this when I was a kid, don't tell me you didn't do it, because you did, and your kids do it. If you have older kids, you've seen them do this.
You didn't do it.
Right, that? Right, and then do this. I did that. I did that until my 30s. Right, so or this, 27, and then when you have kids, when you have these long numbers, 6, and we're subtracting other numbers, and they've got this, and then they've got numbers written, and then some of them more are crossed out, and we got numbers written on top. And if you have especially a boy or kids who are not careful writers, this is a disaster. So what we want them doing is working with numbers that end in 0, 1, 2, and 3, because they're not going to be making mistakes. So we want to take problems that are hard problems and make them easy. Yes. Yes. Okay, so we're going to delete that. So we can take some more problems, and this is pretty simple, the getting up to 10. Lacey has worksheets for this. She has what she calls if you played the lock and key game. Who's played the lock and key game? Yeah, okay. So she has what she calls a special, new share. Hold on. Let me go back to my whiteboard. New share, screen. Okay, we need to go back to my rods. Okay, so the lock and key game. Let's do a smaller one. Okay, hold on. I need another. So she'll have something like this, and what you're going to do is put a key in there. So here's the lock. So we've got a lock here, and what we want to do is first get this number to 10. So you will put the white rod in here. So you would just lay out your rods, and then you put the rod in that will match. So we're going to take our 9 plus 1 and then add 2 more. So 12 minus 9 is 1 plus 2. And she did another thing where she put rods underneath. Oh, I think she did it like this, so that you could see the connection. So she had the other one, so you had 1 plus, so you would see that it was 3. So she makes that same, so her subtraction packet, and she's redoing it, I would show it all to you, but she wasn't finished the last time I talked to her because we were trying to make this all consistent and really, really clear. So that's how you do this to the plus 10, and we want our kids, so the facts that you're going to be working on, your 10 facts and your 9 facts, and I will show you why we're going to be doing, well, that you see all from 9, last from 10, but we want them to pretty much know their 10 facts, their number bonds in 10 and their number bonds in 9. And how we did this to learn them, and it helps them to do addition later, is we just took 10-sided dice. And Catania will have you do it by grabbing a whole pile of rods. It doesn't matter how you do it. And if you grab a whole pile of rods, just throw a bunch of them out. Let's scatter, right? Like they're scattered. You go through and you find 10s, right? Just go pick them out. Or you can do the same thing with dice. we did the same thing with dice. You roll the dice, you shake them, and you find the rods that make 10. Find the dice that make 10. And the thing with dice that I really liked is you can't always make 10. Maybe you have, when you're adding up, you have 3 8s. So we got it's like the 10-sided dice, and I think we got a package of 10 off of eBay for like $6. So maybe you have 3 of these 8s, and you have a 6, and there's no clear 10. But then what my son figured out is that you, without having to add it up, that each 8 was missing 2, and he knows that 3 of the 2s make 6, so he could just add a 6 on the end. And then he could just see that it was 30. He didn't have to add each 8 up and then add 6. He could see that there was 6 missing, and he could add a 6 and then add the 10s, which was then 30. And he can now do this really fast in his head. This isn't like all these steps take a really long time. If they work on it, it becomes just a mental game that they're playing and shifting numbers around. And here's where we're going to go. What time is it now? Okay. With this, does anybody have any questions on this part so far? Adding 10s and then adding beyond, or the place value thing and what you would do with that? No one? We're good? Okay. When the kids are little, I would have them, and Lacey does it too. If I had 18 minus 9, I would actually go through and have them write 9 plus 1 plus 8. I would actually have them change that. And then when they get really good at it and they can do it mentally, then I would drop it. But in the very beginning, I would actually have them rewrite the problem so they can see the steps in their head. But here's where we're going with all from 9, last from 10. Let's say I have 100, and we want the kids to play around with this. And I said we had, that when we had 3 fingers up, we were doing reciprocals. What did we have? Andrea, what was our problem? We had 71, and it was 29, right? Okay. Let's do that one first. 71 and 29. So we have 100 minus 71. And I said we were going to find reciprocals in 100. Well, there's only 2 numbers here. There's only 2 here. So my son was really confused when I said, okay, we each have 2 fingers, or we have 2 sets of hands, and we're going to find reciprocals in 100. Well, I don't have 3 zeros. That's not 100. We have 3 numbers that must equal 100, right? So then we have to figure out, why are these 9 and this one 10? And if we add these up, this is 10. Oh, hold on, 71 and 29. This is 9, and this is 10. That doesn't look right. What happened? Alex, what happened? I told you we were doing reciprocals in 100. Does this equal 100?
Reciprocals in 100?
Yeah, we were going to find number bonds in 100. What happened? Is that 100? I added those together. That's not 100. What happened?
900. You added 900, 800 more.
Well, did I? Is that what I did?
Yeah.
If this is tens and this is units, and I have 7 tens and 1 unit and 2 tens and 9 units, and I add them up, I have 10 units over here and 9 tens. I thought I said I had 100. What happened?
You added 800 more.
So I have 9 tens and 10 units. What's going on?
The line is the middle. Is that like a 1 off?
Well, that was like, so this was, yeah. Who was here? Who had, so this is, Robert's iPad. Your name is
Yes. Jenny.
Jenny. So that's why I put a J there, just making sure I don't want to call you the wrong name. And then we have Holly over here. These are Holly's fingers, and these are Jenny's fingers. So Jenny had 7 fingers up, and she had 2 fingers down. And Holly had 1 finger up, and she had 9 fingers down. So these are, so I have them separated. And Holly had units, and Jenny had tens. So what happened there? Do we write numbers like this? Do you notice anything weird?
Yeah, whatever is weird.
Maybe your mom knows what's weird. Do you think she can find out what's weird?
Already guessed.
What is it? What did you guess?
That Mommy could find out that
Oh.
something's weird.
Oh, your mom, you think your mom can find out what's weird? Can you can't find out what's weird? So do we write 10? Do we say 90, 10, or do we say 99? What comes after 99? Does 90, 10 come after 99?
100.
Oh, so I have 10 units. What am I going to do with those?
Now you put them in a tens column.
Oh, they're in the wrong spot. Got it. Okay. All right, so I'm going to put a 0 there.
Yeah, I noticed something finally.
You did great. So what's going to happen when I have 10 tens?
I did the opposite. Horrible.
So what happens if I have 10 tens?
1,000.
If I have 10 tens? Let's count by tens.
Oh, I thought you meant like 10 hundreds.
Okay, so what happens when I get 10 tens? How much do I have?
100.
All right, so now I need somebody else's. So what happens is I'm going to take this 10 and I'm going to put 0 tens, and that's going to go all the way to 100. So what do you notice about here? Let's do this in 1,000 now. Let's find fingers in 1,000. We did one. Andrea, we had one, right? Where we had 3 digits. We read off a number.
You mean 765?
765. And I said that we could find the reciprocal in 1,000. So Holly, this is Holly's hands. Holly, she was the units. And this is Jenny's hands. She's our hundreds. And whose hands were over here? Was this Union's hands? I think it was. These were Union's hands, and she's 100. She's hundreds. She's 10. So Jenny's tens, Union's hundreds. And we didn't have anyone over here. So they were only allowed to have fingers that were equal 9. So if Union only had 9 fingers up, or 9 fingers, and 7 were up, how many were down? Alex, if 7 were up, how many were down? If you could only have 9. If you have 7 up, how many are down?
3. 3 are down.
No, remember, this one's cut off. You have to act like this one doesn't exist. We cut that finger off.
Oh, you cut them.
So which fingers are down? These right here.
The 2.
2. So if 6 fingers are up, how many are down here? If 6 are up, how many are down? These right here. Can you remember? If 6 are up, Alex, can you remember what that number is?
Oh, down.
Okay, 3 are down. All right, and if 5 are up, we get all 10 fingers. 5 are up. How many are down? I'm going to just say 5.
5.
5. Now let's add these together. What happens? 5 and 5 is what? So 5 and 10. 6 and 3 are what?
3.
6 and 3 are
6.
6 plus 3, Holly.
Oh, 9. I thought it was 3 plus 3.
okay. 7 plus 3 is, or 7 plus 2. 7 and 2 is the
9.
same as 9. So we have that same pattern. 9, 9, 10. So we're going to call this rule that when we subtract numbers from something that ends in 0, all the zeros, when you see them, we're going to change all the numbers to 9s and the last one to 10, and we're just going to add up. So all from 9, last from 10. So we can find reciprocals in all the way up to 1 billion. How far do you think we could go with this, you guys? How far do you think we could go? So we did reciprocals. We subtracted numbers in 1,000. If we do all from 9, last from 10, can we do a really long number? Who thinks we can? Let's do this. 7, 6, 5, 9. Oh, wait. No, we're not doing that. Sorry, I'm erasing. We're going to do, how long should we go? 7, 0, 0, 0. 0, 0, 0, 0, 0, 0. How far do you think we could go? Alex, can you subtract a number from this number, or is that too big?
1. Actually, 7 million.
What number is this?
7. 7.
I don't know what number this is. I'm just writing.
I know.
That was funny.
Okay. We're going to use all from 9, last from 10, and subtract this. And we can start on this side. So let's make this a 1 instead of a 7, just for now. And we can do this. 6 from 6 to 9 is how much? All right, anyone, not just Alex. Putting Alex on the spot is nice. So we can do 1, then what?
8, 0, 9, 4, 8, 5, 0, 2, 3, 5,
8.
8,
Alex, what is it?
5.
And this last one is going to be what?
10. Number of the last from 10.
It would. 6.
Now remember, our rule was what? Every one of these will be 9. This is 9, 9. We don't even have to write them down. 9.
7.
This last one will be what?
7.
Okay, but what is this last number here, though? If these are all from 9, what is this last one going to be?
10.
10. And this is how we make change. This is if you're counting back, if you're making change, this is how you're going to do it. If you hand somebody a $20 bill or a $10 bill and it costs you $9 and some change, this is how we're going to make change. And then where this goes, we want to practice doing this. We need to learn our our number bonds in 9 and our number bonds in 10. We're going to mostly do that playing games. Lacey has a poem for 10 friends, the magic 10 friends. If you want to go do that. I don't know if you guys have others. We just played games with dice and throwing rods on the table and physically putting them together. Where this is going, which we're going to work on because I'm just about done here, for moms and dads, so that moms know, is let's say we have, let's say 20, and we're going to subtract, well, we're going to do ones first. I'm going to do it easy. Let's say we have 125, and we need to subtract 96. Well, we could add 4 to each of these and turn this into 100 and this into 129. But we can also do all from 9 last from 10. And we're going to change this into 100 minus 96. And we know, because we worked on place value, that this is 100 and we are adding 25 to it. So we have 100 plus 25. And all we have to do is subtract the 4 and add that 4 to the 25. And now we've changed this in from a subtraction problem into an addition problem. And eventually, how this happens is where we're going. So we're going to play around with this next week. Is that your kids will go from having to separate them out, like I said before, to just being able to add the 4 here, right? We know this is all from 9 last from 10, right? So we just add the 4 here, and this will be 1 less, and we just have 29. And so we don't have to worry. We just count up here, and this is 0. And that's it, 29 by adding. And we never have to do this, which I think is the torture of small children. Turning this into a 12 because that's what I would have done. And that's not enough, so I have to cross this off and make this 11 and then make this 15. That's a giant mess. Any questions? We're going to play around with this part next week a lot. No questions? We're going to use all from 10, all from 9 last from 10 comes in all kinds of places. So it's not just for subtraction that we'll be using it. You're going to use it all over the place. No questions? Alex, do you have any questions?
Nope. Oh.
So you're going to be able to come back next week and tell me how many large numbers you subtracted, right? With lots of zeros. Like, how long can you make it? Next week, you're going to show me lots of subtraction problems you did, right?
Shucks, that's my worst. That's my weakness, math.
No, we just did it, and we did a really long one, and you said it was easy.
No, it was hard. It was harder than anything.
That was, you just have to be able to count up to 9 and count up to 10, Alex. It's really easy.
Really hard. Yes, you're so correct.
All right. Jenny, do you have any questions?
No.
Okay. I know Frankie's already doing this. Jeanette, do you have any questions? Your older ones are doing this too.
Sonia, this is Victory. Can I talk to you after this meeting, or do you have other things to do?
Maybe for a little bit. Well, I'm pretty much done now, and if nobody has any questions. So we can be done now, and then you can keep me for another 10 minutes. Or if they want to stay, are they questions that anybody else can hear? Or do you want to just talk to me? Because sometimes your questions help other people.
Well, I think I missed a lot of it, so I just wanted to ask you a few questions about it.
Oh, well, everybody can leave when they're ready, so go ahead and ask. Go ahead.
Okay, I'm not quite sure how this connects when you're doing subtraction with the numbers at the top are smaller than the numbers at the bottom. I think I missed that.
Okay, so where this goes, and we're going to be doing this a lot next week with big numbers and small numbers. We're going to do all from 9 last from 10. And we want the kids to really understand this. But what we're going to do is if we have, say, 237, and because it's not always going to be single digits over here, right? That's not going to always be a 1. So it's not going to be an absolute reciprocal. And we have 135. Oh, wait, that's not smaller. Let's erase that. Let's do 179. Right? What we know, because Cuisenaire has you playing around with place value, is that 200 is really, we can say that it's 200 plus 37. And what we want to do is take the 179, using all from 9 last from 10, from 200. So we know that I would want to have the kids discover this for themselves. I wouldn't tell them. But this one will be 1 less. This one's going to be 1 less, so this is going to be 0. And then we're going to add up here, from here, 7 to 9 is 2, and 9 is 21. We're going to count up to 10, and here we're going to count up to 9. And we're just going to add the 21 and the 37 together. And we just changed it from a subtraction problem to an addition problem. And eventually, once they do this, they won't have to do this step. They'll be able to do it mentally. This method, the all from 9 last from 10, was designed so that you could subtract left from right and you could do it in your head. But in order to have it make sense, I would do this part first. Does that make sense to you?
Yeah, I think I'm starting to get it.
Yeah, we're going to do it next week because I had somebody ask me, well, how do you know where to split the number? Like, where do you, so let's say I had, and we'll do this next week, but let's say I had, 1,765, and then I had 986. All right, where do you, what part all from 9 last from 10? Well, you can see here that you can't subtract 900 from 765, so you must take it from this 1,000. But if I had this, right, if I just had this, I could take this 86 from 7, so I could separate it. And put 65 over here. And then do all from 9 last from 10. So then I would have 1614 plus 65. And that's 9, and that's 7, 6, and 1.
Yeah, I see what you mean.
So that you're gonna have to be able to figure out, and that's why we're really actually talking where when you're doing this nonsense up here, you have no real sense of place value of what's actually happening in the subtraction. The math, this did not help me. This mess up here never helped me understand place value. Like we have all we're doing is moving stuff around, and when you do the same thing with addition, and when do I move to the, when do I regroup here? This becomes a mess. Whereas this really does help you understand what numbers you're taking around, because this isn't, when I do this, and I take one from here and make this a 6, and I turn this into 16, this is not 16, right? This is 160, right? But that's all lost. That's all lost. This isn't 6, this is 600. So doing this, the kids actually have a really good grip of what we're actually talking about and what we're really doing when we're subtracting or when we're dealing with numbers in general.
So my other question was, we have been reading through the Common Sense of Teaching Mathematics, and we've started with learning the finger combinations like he does in the book.
Mm-hmm.
And I noticed your chart is a little bit different to his in the book. You've got 10 down under the 1 instead of up on the other end. I'm just not sure how that works compared
You
with
put it
his.
either one. I don't know that it really matters. Hold on. And I've seen it written different ways. Hold on. I put it on a new column. So you're saying, hold on. I'm trying to find my, there we go, my mouse. So you want the 10 over here?
I just didn't know if it was different or not.
This column here. So do you want the 10 over here? Is that what you're saying? I don't have that book right in front of me, but I know what book you're talking about. So does he have this chart in the book?
Yes, he has the, you make it up one row at a time.
Okay. And then does he place the 10 all the way over here on the right? Does he have another row for 10?
Yeah.
So what does he have? What does he have under the 1?
I can't remember.
Because I think if I look it up online, let's do the Gatenio chart. Let me get that thing. I think they're almost all so that you can see it. All the ones that I have seen, and I haven't obviously looked in the book, but you can, here's one. Let's see. We're going to come up. It may not do it with my, okay. Yeah, they have them going from 1,000 this way so that you can multiply and divide by tens. I have not seen it over here, but I will look at that and I will get back to you next week and let you know why he did it that way in that particular situation. Because I know almost when I've seen it, and I haven't read the whole book. Or I don't know that I noticed the whole book. I know that Alf Coles uses this same one. And so did Dick Tata. So.
Yeah, it makes sense.
Yeah, and I didn't go all the way to decimals because I wasn't trying to teach about decimals. If I were going to teach about decimals, I would reduce these and go back the other way so that they could see. But I'm doing this because I have a child going from numbers inside 20 to numbers up to 1,000,000, and we did this in one afternoon. So we went from adding and subtracting numbers inside of 20 to doing reciprocals and adding and subtracting numbers in 1,000,000 in like 45 minutes. So it was fairly painless when we did the fingers and then we did the chart. And then I felt pretty much like we have multiplication down, we have this down. I don't have to do math all year. I'm kidding. It's like, wow, we just skipped a couple of grades doing this. This was really fast. Yeah, this is how I've seen it, but I will look and I will get back to you.
Yeah, I really love his use of fingers because kids tend to want to use them anyway, but they always use them randomly and they never remember what they see. So I like the way he actually gets them to notice what they say about them.
Yeah, and I like it that you can instantly look up, right? So even if I don't know and I can't subtract 45, I can, you know that each one of your fingers, each set of fingers, when you're subtracting, if you do 9 or 10, depending on where it is, you can refine that reciprocal and you can go through the whole entire set if you need to. Like if you can't find them, if you have, you know, if we're doing 900,000 and we're taking some number from 900,000, I don't have to know what that is. I can do for each place, right? Each one of these, I can just do each one with my fingers and find the other side by just up fingers and down fingers. But it's not just taking your kids. If you read the Common Sense Teaching of Mathematics, the other thing that you're laying the foundation for, if you play around with this and start really thinking about up fingers and down fingers and the different ways, and I would have them do it, not just 7 this way, but, you know, 3, 4, 7 this way, and let's put one over here and one down here, 7 this way. What you're talking about is laying a foundation for combinatorics, because we use the word 7 and it covers an awful lot of information. It covers 7 covers all of the possible combinations and permutations in the black rod. That's a lot of information. And so lots and lots of ways that we can make 7, and I would have them play around with it. And no matter which way you do it, that's the other thing. No matter which way you arrange these, there's still, you know, there's still 7 up and 2 down, or 7 up and 3 down for 9. Anything else?
What was the name of the book that you're discussing?
You can find it on ISSUU, and it's free. And then you can look up an ISSUU downloader, and then you can just print them off. So, and it's called The Common Sense Teaching of Mathematics. And he goes through this whole finger exercise. And then he goes through the combinatorics things, and he's going to give you some equations there. I didn't bother going that far, but yeah, he has a lot of like how to move your kids from, and I would do this exercise sometime between book 1 and book 2.
Okay.
And the kids love working with large numbers. It's a huge boost. So had Alex really not read large numbers before? Jeanette?
Not really, no.
And that was
No,
painless.
Yeah, but like you're saying, you know, there's definitely that attraction. It's like they see these big numbers, like, because he sees what Benjamin's doing and he's like, oh, you know, and he's super excited about it. But yeah, but we're so patchy because he's not able to pull the information out always what he wants.
Well, that's why I kept going back. If this is 300, what's this one? If this is this, then what's this? If this is 40, what's this? So I was trying to give him the name first and then have him reason to the next one instead of making him come up with it first.
And it worked a treat.
Right. And then the confidence booster when we can read those is huge. Huge.
Yeah. But I feel all of it that we've done, because I really haven't pushed it with Alex. You know, we haven't really progressed much. You know, like how you always talk about with Philip, how you stayed within those numbers 1 to 10 for such a long time. But it's only when you come and do things like this, you realize how much more that they're actually doing in all these, you know, activities, that really, yes, it is within the 1 to 10, but they've got such a solid foundation, how easily it transfers out beyond those numbers. That's what I've noticed.
Yes, painless. I find it was a painless transition that that we didn't have to do numbers up to 100 this year, numbers up to 1,000 next year. Like, we just did it all in one afternoon, and it was very painless. And the chart for reading the numbers, this was like brilliant. And to see the relationships. And as that powers of 10, he doesn't address it here till book 5, but you can clearly see then the powers of that, it's all multiplied by 10. And I knew that, we always laugh about how I didn't get it. That's my thing, that I didn't, this is powers of 10, duh. but when you see it written out like this, and you can create any number this way and to have them reading it is really helpful.
You know, I was the same, and it was literally only a few months ago with the decimals, because Benjamin's just started dabbling in decimals. And I was talking about, well, you just move the decimal point. And my husband, he was home one day and he said something about, you know, well, it's kind of dividing by 10. And I'm like, no, he's moving the decimal point. And it just didn't strike me at all that it was the exact same thing.
Yep. Right. We're multiplying. What was the same thing? Powers of 10 multiplying by. I knew we were multiplying by 10, but it just doesn't, you know, it doesn't register. The towers, when you get, we're not doing that right now. We can, I need to quit here soon, but doing the towers was huge for me. The powers of 3 and the powers of 2 when we're multiplying by 2, and seeing that in the towers was pretty impressive too. Like that, just towers was, I mean, all of this rocks my world. So, I mean, just in how easy this really is.
You know, we're doing this thing we've started. It's a structured word inquiry. So I'm learning Latin orthography for beginners, and it's this old English eccentric guy who's doing it. And every time somebody's noticing something, because he's not teaching us Latin, he's teaching us how to look at the English language and figure out how it's constructed, where there's Latin bases and things, and all the suffixes and everything like that. And so every time anybody notices something or asks a question, he's like, and that's what scholars do. They notice things. That is a scholar. And I immediately am like, there it is again. You know, notice and wonder.
Yep. I was teaching a class like last Saturday, and I had one of the moms say to me, look, I am sick of noticing and wondering things. I don't know what I'm supposed to notice and wonder. It's like, yeah, I totally get that. Well, listen, I need to get going. And we will play around with this more, all from 9 last from 10, next week.
Is there any baby news?
Yes.
Is there baby news?
What?
Is there baby news? Andrea, I'm looking at you.
No. Otherwise, I would have told you. Don't worry.
Any day. She's like, are you overdue yet? She's overdue.
No, 11. No, I'm not, Sonia. It's 11 October. Oh, 11th. It's on the 11th.
Okay,
That's
why did I
day.
think it was the end of September? I'm like, she's
because
overdue.
I said that to everybody. I was expecting her sooner, but she doesn't want to come. So I'm like, okay, fine.
Okay, this whole time I'm like, she's got to be irritated by now. She's like long overdue. And I remember saying to you, watch, it'll be like 2 weeks overdue.
In 3 days, I'll start asking questions.
So will we.
Okay.
Okay. Thank you for today, Sonia.
All right. You're welcome.
Yeah,
We'll talk to you
thank
guys later. Bye-bye.
Thank you so much. Bye.